I'm on page 93 of the homework exercise book, and we're looking at question 9. Consider the following linear equations. Which graph represents the solution to this system of linear equations? Well, I think the first thing I'm going to do is get them both in slope-intercept form. This may not be necessary, but it's a good practice just in case you ever have to do that. So let's see what we've got here. The first one is x plus 2y equals 18. So I need to move the x, and I'm left with 2y is negative x plus 18. Divide both sides, all terms, by 2. And so I'm left with no more room. Let me pull it right here. So I'm left with y equals negative 1/2 x plus 9. So I can tell you that the slope of this equation is negative 1/2, and the y-intercept is 0.0 positive 9. All right, let me do the other one. Same thing, I'm going to put it in slope-intercept form. So I have y equals mx plus b as what I want. And for what I have negative x plus y equals 12. So I'll add the x to both sides and cancel. And I'm left with x plus 12. So the slope on this one is positive 1, and the y-intercept is 0, positive 12. Now with that information, I think we can find what we need. Actually, let me do one of them in yellow, and we'll see. All right, this first one, so this is saying that we have one slope negative and one slope positive. That means they will intersect. And unfortunately, all of these intersect, so that won't help me, but that would be something to check. Okay, let's take a look at y-intercepts. Let's approach it that way. So at this one, here's the y-intercept for this line, 0, 0. Now, neither of my points have that as the y-intercept, so this is not the answer I'm looking for. Okay. Here we have a y-intercept of a little more than 8 negative and almost 12 negative. So this is 0 negative 8 and 0 negative 12. So do those match the y-intercepts? They do not. So B is not the answer. C, we have a y-intercept of, let's see, each of these is 2. Is that right? 2, 4, 6, 8. About 8.5 and 12. I'll go with the 12, but the 8.5, that's awfully close. 0 and 12, 0 and 8.5. Let's see. Let's keep that one. Okay, this one we have a y-intercept right there. Neither of those, 0, 4 is nowhere near what I need. So let's take that one out. And this one we have a y-intercept at 0, 0, and then up here at, 7? So that doesn't fit. So the one that's closest on the basis of y-intercepts looks like this one. And we do have one negative slope and one positive slope. So on the basis of my y-intercepts, I'm going to guess that it's C. Let me look at their answer and see how they approach that. This is number 9. Okay. They did not approach it this way. Oh, their way is better. The answer is C, and I was close enough to get that answer, but here's what they did, and I do want to show you this because I'm not comfortable with close. I want it to be exact. So here's what they did. They took the graph. Now this would take some very serious time, but here's what they did, and I'm just going to show you with this one the proof that this is indeed the one we want. So draw yourself a table of values, and this is going to be for the first of the two graphs. Remember, we have a system here. We have two lines. So they have taken one graph, and I'm going to erase my points. Let's do them in blue for one of them. So let's take this negative slope first. So the x's and the y's for this one, I see a point there. I see a point here. And I see a point, where? Right here. So we have -6, +12. We have -2, +10. And then we have 6, 6. And that's enough. Okay. So those are the points for that particular line. And let me just try, I know this won't work, but let me try to make it did work. Let's make it blue. Then we're going to do the same thing for the other table. So let's draw another table. Mark X and Y's, and this time I'm going to look at the other line. And I'll do it with black dots. So I have a point here, clearly. I have a point here, and I have a point here. You could pick lots of them on this one, but I'll only do 3. So we have -1, +10, -2, because each box is worth 2. And then I have -6, +6. And then I have -8, +4. And the way that they determined that this is what we're looking for is that both tables have the same point. That same intersection point is in both tables. So they would say that on the basis of that, we have the same intersection. And that's how they chose C. The point where the two lines meet is the solution. All right, finally, we have number 10. It says to do the same thing, basically. We're going to take these 2 points and figure out which solution is graphed, which of the graphs is the solution. So I'm going to do the same process. I'm going to do slope-intercept for, did I have to do slope-intercept? I did. All right, so we have 3x plus 5, y is 20. So I'm going to move my 3x to both sides and cancel. So I'm left with, again, not enough room. Let's bring him right here. So I'm left with 5y equals 3x negative plus 20. So I'm going to divide both sides by 5. And I'm left with y equals negative 3/5 x plus 4. So you have to divide that one also. So there's slope intercept for that one. So slope is negative 3/5, and the y-intercept is 0, 4. And then the other one is going to be 4x minus 5 is 15. So I'm going to move the 4x over to this side. And I'm left with negative 5y equals negative 4x plus 15. Divide all terms by negative 5. And that leaves me with y equals 4/5 x minus 3. So slope is 4/5 positive, and the y-intercept is 0, negative 3. So one slope is negative, one is positive. There is an intersection, I would expect. And let's check all of them to be sure. All of them intersect, so all of them could possibly be the answers. Let's check the intercepts. Each box is worth 2 in all directions in this one. So 0, negative 3 would be down here. That doesn't fit. That's not it. Okay, this one we have a 0, negative 2, but that's not one of my intercepts. This one we have a 0, negative 3, and a 0, 4. That one could be it because the intercepts match. So let's put a question mark there. This one we have 0, 0, and a little bit below 2. That doesn't fit, so that can't be it. And this one we have 0, negative 4. That doesn't fit. We've got a 0, 4, but that would be above. So I think we've got this one. B doesn't fit, does it? No. And neither does A. So on the basis of the intercepts, I'm going to tell you that this one is C. Now this is not how they wanted me to solve it. Let me show you how they want me to do it, because that's what I'm supposed to do. Table of values. For both of them, so I need 2 tables of values. And let me just copy that one, and I won't have to put you through sitting here while I'm... Okay, so for the first line, I'm going to take the one with the negative slope first. So we have 0, 4. We have 5, 1. And that looks like all of them that are sitting on an intersection. Then for the other one, here's the red line, excuse me. This is the red line. And then I'll make this the blue line. So for the blue line, we have 2 good points. We have 0, negative 4. That doesn't match, but this one does. 5, 1. That's the intersection. That's the solution to this equation. Because both tables have that point, that is the solution. It's the one they have in common. So x of 5 and y of 1 would make either of these equations true. And let me show you what I mean. 3x plus 5y was what, 20? Yes. So 3 times 5 plus 5 times 1 better equal 20. 15 plus 5 is 20. It will also work in 4x minus 5y is 15. 4x minus 5y is 15. So 4 times 5 minus 5 times 1 is 15. And that's 20 minus 5. That checks out as well. So that tells me that that solution is the true solution. It's the one that fits both equations. So the answer to number 10 is C.